Hello, my friends. Our topic is the R software. I'm going to give an introduction to R. It's a statistics program. That might sound boring right off the bat, like, oh my God, just how to use a statistics program, one of the most boring things imaginable. I think you're going to love this. This is amazing. The R software is incredible. It's extraordinary. It's one of the great breakthroughs in information systems in modern times. I mean, that's how important the software is. That's just my personal opinion. It's unbelievable. And what you can do with it is unbelievable. If you want to know if, some artificial sweetener or artificial coloring or whatever is associated with some particular physical disease or whatever, as long as you have data, as long as you have information, and that data was collected well, you can find out. This is how we understand things in the modern world, and this software is a real blessing. It's just amazing. So I'm going to tell you why people use R, and as wonderful as it is, there's never one solution for all problems, why you would not use R. And then I'm going to explain how you install the program, and also something called RStudio. You can run R without RStudio. RStudio is like an option that you can have. I use RStudio. A lot of people use RStudio. Some people use other things. RStudio is extremely common, very popular. It just helps with creating your R script. I'll introduce that term now. The R script is the instructions you give to R. Now, one of the disadvantages of R, which I'm going to discuss on the next slide, but to preview this, is that you do have to create this script. You have to type in stuff. And as soon as people hear, oh my God, I have to type in things, rather than have little buttons that say, oh, give me a t-test, give me an ANOVA. If you don't know what a t-test or ANOVA is, they're statistical tests. And here's my data set. That is easier. There are graphical user interfaces that people have written into some parts of R, but most people still just type in. So that's the big stumbling block, but it's really not a stumbling block. I'm going to show you what you have to type in. It's easy. It's not that difficult. So I'm going to get you oriented to how this is done. And let's start off with topic number one, why you want to use R, why you wouldn't use R. Then I'll talk about installation. Then we're going to see a script. We're going to see what we do. This is going to probably take 2 or 3 videos. I usually like to stick to about a half hour. So we'll see how long it takes me to go through this, probably 2 or 3 videos. Okay, why do you want to use R? And then at the bottom here, why you do not want to use R. Okay, I give 7 reasons to use R. Number 1, what do you want to do? Do you want to do data mining with artificial neural networks, things called random forests and SVPs? Do you want to just do a basic t-test? Do you want to do an ANOVA? Do you want to have some beautiful 3D graphics? Do you have some really complicated advanced thing with some more technically complex thing? Do you need to integrate different kinds of files? What do you need to do? You do all of this with R. You can do almost anything you can imagine. And why is R so capable? That gets into point number 2. It's a free program. It's totally free, and you can get access to the source code and improve it. And hundreds or thousands of people are not only using R, but they're improving it. You, if you got deep enough into this, could add your own stuff. Why do you want to add your own stuff? Because researchers are constantly wanting a new way to visualize something, a new way to extract information. They realize there's a new, we call them parameter, a new feature to a basic analytical process. Statistics is not just like little boxes, like, oh, give me a t-test, give me an ANOVA. There's like things in between, complex situations, ways you want to look at stuff. It's not all about just the numbers, your ability to visualize, see what's going on, combine things together, separate them out. Wow. R does all of this because R is the program that many cutting-edge researchers are using to develop the ideas. They develop them in R. So they're creating a new data visualization, they create it in R. They have a new statistical analysis or improvement to something, they often create it in R. So as it's created, boom, it's immediately available. And if it was not created in R, somebody's going to implement it. Every university in the world is using R. It's very widely used. So, number one, you can do almost anything in R. Number two, it's free. And those two issues overlap. One reason why you can do anything with it is because it's free, because it's open source, because it's cleanly developed and organized. Number three, you don't have to worry about this Windows versus Mac versus Unix problem. It runs on all three, and variations of Unix, by the way. So you can install it on all those platforms. R is being developed, improved so massively all around the world, things are just becoming available. And number four, I've kind of hinted at this, not only the calculations, but the graphics you can do in R, stunning. There are literally thousands of what are called packages. The packages means the little code that somebody wrote. So suppose you have a professor, whatever, University of Cambridge or somewhere, anywhere. And that professor is working in biostatistics with maybe 15 graduate students and a few other professors, and they have this way they want to look at stuff. They will develop the analysis, they'll add new graphic capabilities, and if they add features to R, they're putting something called a package. So here's what happens. You install the R software. Nothing to it. I'll show you. You install it. What you're installing is what we call the base R program, just the essentials. Because if you installed the complete R program to do anything that R can do, you'd probably be waiting for hours. It's thousands and thousands of packages that you're never going to use, most of them. So it's beautifully designed. It installs pretty quickly. It's not that big. And then as you need things, you install packages. So somebody creates, say, a new data mining thing like random forests. Not brand new, but relatively new, and new insights into random forests come about, new ways of setting up your random forest, new default settings. Almost every cutting edge thing about random forest is available in the R program, as with anything. And how do you get all that? You install the package that somebody somewhere wrote. How do you find out about it? You just do a Google search. You just go to Google, type in random forests or data mining or whatever you want to know about, and then put R software or R statistics next to your search. And you'll get tons of wonderful information about how to do it. And what it will tell you is it'll be in a package. So you install the package. I'll show you how to do that. You install the package and you have access to it. My main point is this. The R software has almost endless numbers of calculations. You do not need to install all the software, which would use up a lot of disk space and everything else and take a lot of time. You install the base and then you just download what you need as you need it. That's the idea. It's beautiful and it's all free. So I'm up to number 5. Online help is wonderful. The whole world is using this. Everybody's contributing. So there's lots of information. Number 6, this is so cool. R, which is free. A lot of times free programs are a little bit on the cheap side. They're not, maintained very well. And that's true for some free software. This is not true in every industry, but in statistics, R is used at the most cutting edge of research by some of the most advanced and sophisticated researchers in the world. So it's highly respected, it's highly authoritative. It's used in the most advanced academic research, as well as beginners using it. So you've got this free program, does anything you want, it's easy to install, it's just expandable, and it's extremely authoritative. And one of the things that makes it so authoritative is all the options. So when you're running even a basic test like an ANOVA, it has all the different kinds of options that some people might use in different settings. And it can present it beautifully. And the other thing is the flexibility, because R is not just statistics. You can manage files, you can merge files, you can separate things out, you can integrate in with different programs. And so you can do low-level, what we call low-level calculations. You can do complex projects. All of this, and it's free. It's just amazing. It's one of the standard, most powerful things, getting stronger and more important every day. Now, why would you not use R? Well, number one, if you just want a t-test or something simple, you can use a program like SPSS or any other number of other programs that's, comes with a standard user interface, tell it what the data is, get your results. So that initial thing of having to type in commands is, you might say, a small barrier. You'll see it's quite small because typing in the commands is easier than it might seem. And there are graphical user interface things people have written into R, but most people are just typing in. So you might not want to use R if you don't want to learn how to type in the commands. After you watch these videos I'm making on R, you will be able to do all this. It's not that difficult. Number two, one of the alternatives to R is Python. Python is a very powerful, flexible language. People write applications, develop interactive websites, and web applications, all kinds of stuff. And Python has very nice libraries. We typically call them, sets of routines written by people to do various kinds of statistics, including data mining. So if you're integrating and you're having all these calculations done within a website, you can integrate with R, but some people prefer Python. Another alternative to R is Mathematica. It's very heavily used by mathematicians and engineers. As the name of the program suggests, it's very heavily oriented for mathematicians, and it has a lot of statistics. Works very well. It's not free. There's a free version of it, but it's just another option that some people like. Number 4, this is one of the big things that comes up, is if you have a billion charts, data, I should say, a billion, we call them rows, a billion, because in a spreadsheet, like each row would be a different subject in your experiment. If you have 10 million subjects or 100 million, and then you have the columns, we also call features, or the independent variables. Usually there's one, maybe two independent variables. Those variables, those columns, usually you might have 10 or 20, but suppose you had hundreds. If you have a gigantic amount of data, you have to use some alternative methods within R. R likes to do everything in memory. Now, I did a test in preparing for this video where I put 1 million rows and there was 1 million subjects. Like if I'm studying diabetes and I had 1 million people with diabetes, and I had 1,000 features like, their blood pressure and their age and male, female, blah, 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 or other gender identifications, whatever. That runs very easily in a standard computer today with 32 megabytes RAM, which is pretty standard for a good computer. So unless you get into a situation like that, you don't have a problem. And even if you do, there are ways around it. But that is an issue with R. So those are some reasons why you might not want to use R. Okay, so point number 2 of the 3 things I want to cover. Third thing is the actual programming, or the creating. It's not really programming. R script, we call it, creating the instructions to tell R what to do. Let's put in. You just type it into the R program, and then you click on Run, and it runs it. So we're going to learn how to create the R scripts. That's what R is really all about. But before you do that, of course, you have to install it. Now, how do you install it? What I do with everything in R is I just go to Google and search for it, because This program is being used by hundreds of thousands of people. And the information is usually clear. I'm always impressed. So just go to Google and type something like install R or install R statistics software. And we're going to use something called RStudio. A lot of people use RStudio. What R does is it provides all these commands, and RStudio gives you a nice working environment. So typically, people install R and then RStudio or some alternative to RStudio. So I use RStudio. I'm going to show you how and that's what I'm going to show you, how to use RStudio and R. Again, R is the essential program. It's the one with all these optional packages, thousands of them, does everything. It's the engine that does it. RStudio gives you a nice environment, we call it, user interface. Gives you a nice user interface for working with R. So I've got a browser up here, and what I did is in the Google program, I typed install R software and press enter, and let's see what happens. If I click on this first one, it takes me to the website for R to download the program. So here's where I would download it and install it. So basically, it's just like a normal installation program. Just download it, click on install. It'll ask you some questions. You keep clicking next. If you want more information than that, you just read this stuff. Just Google it and read about it. I don't want to take up a lot of time with that because it's pretty self-explanatory. I just want to give you the idea. Just type in install R software. You'll see the instructions. You always want to make sure you're not at some malicious site or something. So if you end up at r-project.org, and this one's CRAN.r-project.org, there's a lot of basic things like that, like the installation. So that's a valid website. If I click on this second link that came up for me, let me go down to the third one. If I click on the third one, this is just somebody wrote an article at a website here on installing R and RStudio. And so it's the same thing. You just click on the link to RStudio, and which is here somewhere. And it talks about Windows, Mac, Linux, and a little bit about using R and RStudio, etc. So yeah, you just find the link, click on it, and install it. It says you can download RStudio for free right there. It's at rstudio.com for that. So, and that's also free. The RStudio is free as well. Just install them, you're ready to go. And what you're going to see is you run the RStudio program, an icon will be there. However, if you're using Windows, Mac, Linux, whatever, standard thing, and you run the program, and it's going to look like this. This is what RStudio looks like. In fact, it's going to look more like this. And what you have is in the upper left corner is where you create the R script. Again, this is one of the stumbling blocks for R. You install it and you go, oh my God, I got a blank screen. You mean I can't just click on, here's my data file, click on t-test or something and get the results? People have built a graphical user interface like that into R for certain things, but most people continue to just type in. And that's what I'm going to show you, how you would just type into it whatever you want to do. And one of the problems with the graphical user interface is that R is expanding every day. People are creating these new packages. Remember, package means the calculations, because you don't want to install all the packages. It might take you hours, use up a lot of disk space, etc. When you install R, it just installs the basic essentials. And then when you Google something, it'll tell you what package you need. So here's what you do. You type in whatever package you need. Okay, how do you know what package you need? Just go to Google. For example, let's say I want to do a t-test. Okay, so here's what you do. Here's how to use R. Go to Google and type t-test in R. This is not the only way to do things, but this is one way. And then here's a website, rdocumentation.org, t-test. So because the R software is free, there are entire organizations, non-profit organizations have been created to support this. So you can just read about it. And here's some basics about, you would type in t.test and some additional things, and you would get the t-test. Okay, that one looks like a bare bones information. Let me try this one. T-test and R, learn how to conduct t-tests. That's what I'm looking for. I want a tutorial. I don't want just, this first one will be fine if I'm already familiar with R. Like, what the heck do I do with that? But you find something that looks more like a tutorial. Okay, this looks better. If you need a tutorial. Oh, yes, he's explaining what a t-test is. He's displaying the defaults. He's even going into the theory. There's something called a one-sample t-test, and so on. And then he gives you the code that you would use to get the result, which looks like this, t-test, and then a few things after it, which he explains here. Here's another one. Here's what it looks like. It's t.test, and then the two variables that are being analyzed, usually what we call an outcome variable and a predictor variable in the t-test, and where the data is. And I'm going to show you how you read in data. So you read in the data, and if you called your data CO2, this was for carbon dioxide, whatever, so the file's called CO2, you just read in the data, and you say, these are the two variables that I'm doing, t.test, these are my variables, that's my data, that's it. That's all you do for a t-test. T.test, what are your variables separated with this tilde thing, and then the data you read in. I'm going to show you how to read in the data. It's very simple. So you just read in the data, do your test, you find the thing, and here it doesn't mention anything about a package because the t.test is included. I believe it's included with R. There'll be other options. There's always lots of options in R to do things, and there's undoubtedly some that come in separate packages. Let's do another example. Let's search for ANOVA, which is a common. I just want to show you how to use R. How do you use R? Go to Google, type it in, ANOVA in R, and introduction, okay, stats in R, another website. And they're going to explain it step by step, introduction. When do you use the t-test with tutors? When do you use ANOVA? And what does it look like? And now let me start to show you the code. Here, it's telling you about a package. And some of these, let me scroll up here, it'll tell us as we get into them whether you need to install a package. Some of the packages have data in them. So they're saying, install a package called Palmer Penguins. Somebody did research on penguins. They put that data into what we call a package, something you can install to expand R. And you type in install.packages Palmer Penguins, and then it will give you a data set called Palmer Penguins. There's like endless numbers of these things. And there's all kinds of libraries to give you different features. So suppose you want to just have a data set. Let's do it. I'll show you this thing. Let's take, I'm going to highlight this. I'm going to do Control-C. That should copy it on a Windows computer. Let me go into my R program, do Control-V. It copied and pasted it. This little sharp sign or pound sign or number sign, whatever you want to call it, comments it out, and you'll see that it's in green. I'm going to uncomment it. Now it's in black, meaning it's an actual line, and all I do is put the cursor on there and click Run. And I'm going to install this package. And down here in the lower left corner, it tells you the progress and the results. It says It downloaded it. Package Palmer Penguin successfully unpacked. Now we've installed it. Now, this you only need to do once. That's why they commented it out. I'll comment it out because I've done it. I never need to do it again unless I reinstall R on another computer or something. So you only need to install the package once. If you run it again in the future, it's okay. It won't hurt anything. Now, that gives you that expansion of the basic program, that now it has this additional features that somebody put into a package called Palmer Penguins. There are thousands of these packages. Now, but to use that package, you say library. So there's a few commands. There is a little bit of a language you need to learn. Not a lot, just a little, okay? You need to, it's not a lot. You need to know install.packages. Got it? When you learn about, you Google something and it says you do this, it's going to say it's in a package. Well, what the heck do I do with that? Here's what the heck you do with it. You type install.packages, the name of it, you've got it. That's all you got to do. If nobody tells you this, your head will just spin and you're trying to read all this stuff. So I'm telling you, that's all there is to it. Now you want to use it because you don't want to use it unless you need it. Because you don't want all this stuff running, all this excess stuff. I mean, statistics goes from here till kingdom come. You don't want all that installed and running on your computer. The R program is so elegant and beautiful. You just say, oh, I want this. And it just installs what you need. It's just like you don't need a street map of the entire world for the town you live in. You just need, you get out the section you're looking at. So that's what this is. So now if I run this by clicking on run, and by the way, this is what RStudio does. RStudio is giving us this layout where we type in our script. The results are in the lower left corner. When we do graphics, they will appear in separate files, and we can click on File, Save As, the usual kind of stuff, Save As, and save our script and read it in the future. So that's what RStudio does, just giving us this interface to save our files, see things in a nice way, organize the information. R is the engine that's doing all that calculation. So RStudio and R is perfect, gives us a really beautiful thing. Now, if I go back to that website, it's telling me that I can read in this penguin's data. Looks like there's a file here called let me see here. Well, it doesn't matter. You got the idea. So you can just access these packages. Okay. Usually you're not accessing a package to get data. You have your own data. You're doing it to get new calculations. For example, suppose you want to do data mining. And you've heard about artificial neural networks. So you can type artificial neural networks. You're not even sure maybe, but you're just curious in R. You just type in R. Building a neural network in R. Building a neural network from scratch using R. I mean, like anything you ask about. Then if you start reading about artificial neural networks, also known as ANNs, A-N-N, they'll tell you about other kinds of data mining things, like random forests and all kinds of stuff. And I could just type in random forest in R. And there's information about a random forest in R. Let me click on this. Let's see what it says. And it tells me that I'm going to use a library called Random Forest. So before I can type in the library, you would have to install it, right? This is the basic information. Random Forest, when it says library, means you install that library and it has the same name. So in your R script, you always install whatever packages you need. You install whatever package for whatever. Let's do it. If I type in install.packages, I think I did this before. It's probably already installed. Random forest. I think that's what it was called, or yeah, random forest. Here's a peculiar thing about R. It's case sensitive. So the only capital letter is F. So if you're used to programming and things like that, a lot of things are not case sensitive. R is case sensitive. So I've got just capital F. So I'll run it. My cursor's there, and it's downloaded, package random forest successfully unpacked, blah, blah, blah. There. Now I can use that. And if I go to the website, it's going to tell me how to use it, what to type into my R script, and what kind of results I will get. Almost anything you would ever want to do. Let's summarize. Go to Google, type in whatever you're curious about, like artificial neural networks in R is what I always say. You'll get the information. And what do you need to know? Do you remember? It's probably in a package. It may be in the base system. You don't have to install a package. Usually it's in a package. So you install the package, and then you use the library command to use it. Right? You got it? That's all there is to R. All there is to R is you install packages, use the library, read the documentation on how to use it. One or two other things I'm going to show you, but that's it. That's it. So if we go back to the RStudio program, there it is. Install your package, and then if you want to use it in the future, you just say library. And what some people do is after they run that, they comment it out. So sometimes when you're looking at an example R script on a website, you'll see the install package is commented out. To comment something out, you put this sharp sign or pound sign or number sign, whatever you want to call this thing, or hash sign, whatever you want to call it. You put that in it, and then it makes the line in RStudio, it makes it green, kind of fades it out a little bit, showing that it's a comment. So some people will have it commented after they run it because you don't need to run it again. If you run it again, no problem. You got the idea? You install a package, you only do that once, that downloads it and integrates it into R. If you want to use it for whatever you're doing, you use library. Why would you install it and not use it? Because everything uses up memory. You're using up RAM memory. You're building all this stuff you're never going to use. So the idea is you just download and install what you need and activate, you might say, with the library command if you need it. This way, everything is clean and simple, and you're not getting a lot of clutter, and it all happens fast. It's not taking forever to load, etc. And it's almost infinitely expandable to do anything you want. That's the idea. You got the idea? If you got the idea, you've learned basically what you need to know about R. There's a few more things I'm going to show you. I'm going to do that in a part 2. This is the end of part 1. I'm going to start part 2, and I'm going to show you how to build these R scripts in the next video in this sequence. So let's go back to my PowerPoint. So what we're going to do next is I'm going to show you a script. You've already started to learn about install packages. You know what that is. That's to get these additional features. It's like your R program is expandable. You install just a little bit and it can gets whatever you want to add to it. Then when you want to use a package, you say library. And we're going to learn about these additional commands. This just says what folder am I working with, read in the data, and analyze the data. That's it. You just read it in, you set a folder, you read it in, analyze it. We're going to do this in the next video. There's one more thing I want to mention before I end this video. Next video, I'm going to show you the R scripts in detail. One more thing I want to mention. Let me show you. When I say that R is growing day by day and there are thousands of people, I want to make that a little bit concrete because it's really amazing. Let me just show you this. Let's go back to our browser. And in this search for install R software, I think it was this one. Yeah, this website, r-project.org, This is a nonprofit organization, and over here, somewhere, yeah, it says conferences. And then it tells us about the conferences. And here's some past conferences. I don't know what happened to 2023, but because I'm making this in early 2024, they do have information about the next conference in 2024. The one in 2022 was in Nashville, Tennessee, in the United States. They can be in different countries, France, Australia, Belgium, etc. And let's click on this for information about the conference that happened in 2022. I want to show you this to give you an idea of what's happening in R. This particular person, Paula Moraga, assistant professor of statistics, blah, blah, blah. Paula has worked on the development of several R packages. You now know what that means. She's worked on adding new features to R, so that you just say install package and add these new calculations or visualizations or whatever it is for Bayesian risk modeling, detection of disease clusters, and risk assessment of travel-related spread of disease. So she's working in the area of medicine and the spread of disease. And they had to develop some new analytical methods or maybe visualization tools. They developed them. They're now part of R. This lady here, Amanda Cox, similar kind of thing. One of the top people in graphics, adding new graphic features to R. This particular person, Julius, don't even want to say her last name, I'll destroy it. She's an author, key speaker, focusing on data analysis, machine language, text analysis, beautiful charts. Everybody's got their specialization. Doesn't matter whether it's data mining, standard basic statistics, beautiful charts, text analysis. This fellow, Sebastian Meyer, if I'm saying that right, or Mayer, Institute of Medical Informatics, Biometry and Epidemiology at a university in Germany, PhD in Epidemiology, Biostatistics. He is maintaining the R package surveillance. Wow. People maintaining and developing one of thousands and thousands of packages for specialized purposes. So one of the fantastic things about R is there's no limits. You can get in quickly. At the end of the next video, you can use R. I mean, just a few lines, and you can do your t-test, your ANOVA, your basic things. And then it goes on and on and on. And even if you don't become an expert in R and do all those advanced things, nobody's an expert in R. You just download the package you need, and you use what you need for whatever you're doing. That's how it works. But, if you don't get that deeply involved, you'll have the basic concepts. You'll understand how this works. You'll know what they're doing, and you can communicate and further develop it with somebody who specializes in developing those scripts. And you can get very advanced yourself fairly easily if you want to. But why get stuck with a program that can only do a few basic things and doesn't have all the options and doesn't have the great visualization? It doesn't make sense. And most of them are not free. So in most cases, R becomes just fantastic. Here's another person, a co-author of the book Bayes Rules, An Introduction to Applied Bayesian, another Bayesian, working in Bayesian stuff, and accompanying R package, Bayes Rules. Another package. Thousands of packages. Anyway, I wanted to make this concrete to you, how exciting, cutting edge this is, that when you're using the R software, it's a highly authoritative, cutting edge stuff, cutting edge information system, and you can use it for the very basics and go from there to wherever you want to, and other people can pick up with your R script and further develop it. So if you do a research paper, you can give your R script, they can copy and paste it in, they can run it, you can provide your data, they can easily replicate it, run the script, and they may further develop it. So, R is so friendly that way that it invites people to participate. Okay, next video, I'm at 40 minutes now, let's stop here. Next video, I'm going to go through the R script in some more detail, and you'll see also, not only is it easy to do your basic test, how you can get down into a lot of details relatively easily to find out things. Sometimes even when you're doing basic research, you end up saying, well, why? How is that variable different from this? Can I compare those two variables? Simple questions. In R, it's usually easily done because it's designed to handle all these problems that people are facing in their research. Okay, I'll see you in part 2. We'll go through the R script in detail. Thank you very much for listening, my friends. God bless. Namaste.